Good morning, boys and girls, and welcome back. Today we are going to talk about solving proportions, mainly using cross multiplication. All right, cross multiplying. If you remember, a proportion is when you have two fractions equal to each other. If we look here at some basic review problems, at number one, zoom in here. If I have one fraction equaling another fraction, we call that a proportion. And a lot of times you can do this, you can solve a proportion by just finding the equivalent fraction. Hey, how do I go from 10 to 20? What did I have to do? Oh, we multiplied by 2. So if I do that to the bottom, I should probably do that to the top. And so my question mark would be 6, or this would be 6 over 20, would be the equivalent fraction. So a lot of times we can do this. Other times, it might be the other way around. If I look at the similar pieces here, again, one fraction equaling another fraction, how do I go from 15 to 16? I'd have to multiply that by 4. 15 times 4 is 60. Or you can think of this more like as a reducing problem. Let me divide by 4, and I get 15. So let me divide this by 4, and so that means then x has to equal 4. All right? So when we have a proportion, if you recognize that relationship, that makes these problems a little bit easier. However, I'm going to say that doesn't always happen, and that doesn't always work. If we look at number 3 next, okay? Now I'm looking at 4 and 19. Well, how do I get from 4 to 19? I don't know. That is not one that we can think our way through, all right? And so this is when cross multiplication becomes nice to use, all right? When you have a proportion, a fraction equaling another fraction, and you don't see a relationship, then we can cross multiply. And what we're doing is I'm just going to multiply the x times the 19, and I'm going to multiply the 4 times the 6. Doesn't matter which way you draw your arrows, you just want to make sure that they are diagonal. Technically what we're doing is we're multiplying both sides by both bottoms, but we just draw this to shorthand, call it cross multiplication. So, x times 19, why does it stop writing? Is 19x, now we're writing again, and then 4 times 6 is 24, and what you're going to do is you're going to equal both those sides to each other, and then you can go ahead and divide both sides by 19 to solve for x, and so in this case we get x equals 24 over 19, and that is our answer. Okay, so cross multiplying, not so bad. Maybe one thing we should go back and talk about here real quick though, I know I skipped over on the top here, but whenever you're doing these kind of problems, we're going to have to worry about what we call extraneous solutions now. I believe this is the first time this year that we have started to have to deal with extraneous solutions. An extraneous solution basically is just an answer that doesn't work when you put it back into the equation. Okay? If I go to check my answer, it's an answer that doesn't work. In this case here on the problem of number 3, I don't have to worry about it. But you might be asking yourself, why wouldn't an answer work? Why doesn't it work? And if we go back and we start looking at number 4, the next one we're going to do here, if you remember back to day 4, we talked about when, things at the bottom could not be, when this would be undefined, right? And so what I'm basically going to check for is when I get an answer, if I plug it back in, is it going to make the bottom undefined? If it does, then it doesn't work and I got to get rid of it, okay? But as long as when I plug it back in, it doesn't make the bottom 0, we're okay. That's why back in the case of number 3, I'm not plugging my answer into the bottom, so we're fine. That answer is going to work. There's no issues. But I got to make sure that the bottom of these things never equals 0. All right, on to number 4. Again, when we start getting algebraic expressions, you can't see what the relationship is. So the easiest thing to do is just going to be to cross multiply. And again, it doesn't matter which way you draw your arrows. I tend to go from left to right, but you can do it however you want. Just make sure that when you do this, and it doesn't matter which one you do first, when you multiply, if you've got more than one term, you have to distribute that. So 3 times x is 3x, 3 times negative 7 is negative 21. I'm going to say equals, and then I'm going to go my diagonal the other way. 5x times 2 is 10x. And so now we've got an equation that we can go ahead and solve for x. Get your x's on one side, numbers on the other. If I subtract 3x from both sides, then I get negative 21 equals 7x, And now I can divide both sides by 7 to solve for x. And we get x equals negative 3. Right? X equals negative 3. Now, here's what we're saying is you have to, before I circle that, I should check my answer. Go back and plug it into the bottoms here. 5 times negative 3 is negative 15. I really don't care what the number is. I just got to make sure it's not 0. So that's okay. Negative 3 minus 7, that ain't going to give me 0, right? So we are okay. As long as I don't get 0, that answer is okay to use. If I did get 0, I'd have to cross it out and get rid of it. If it was my only answer and I crossed it out, then you would say there is no solution. All right, moving on to number 5. Okay, so here we go again. We have one fraction equaling another fraction. So let's cross multiply. Multiply here, multiply here. Make sure we distribute negative 4x plus 12 equals, make sure I distribute, 5 times x plus 3 is 5x plus 15. Okay, but make sure you, if it helps you, you can write it out sideways like this. But make sure you go and distribute these things to get that statement right there. And now I need to again get x's on one side and numbers on the other to solve for x. So in this case, if I minus 5x from both sides, I'm going to get negative 9x. Those disappear. And if I subtract 12 from both sides, that would disappear. And I'm going to get 3. Divide by negative 9, and I get 3 over negative 9, or negative 1/3. Okay? And now again, I need to check my answer. Before I circle it, I need to check it. If I plug in negative 1/3, am I going to get 0? No. Am I going to get 0? No. So this is an okay answer. Circle it, and we're moving on. Okay, on number 6 now. Sometimes you have a fraction equaling a fraction, but if you have one fraction, it's generally a good idea. Why don't you just go make it, 2 fractions? See, fractions haven't been that bad. They're our friends. And then once I have the 2 fractions, now again I can go ahead and I can cross multiply. Okay, but to turn 12 into a fraction or any number to a fraction, you always just put it over 1. All right, so 1 times 1 is 1. 12 times 2x plus 25, or 12 times 2x plus 5 is 2460. All right, now I need to again go ahead and solve for x. So minus 60 from both sides, and I get negative 59 equals 24x. And then divide both sides by 24, and we get x equals negative 59 divided by 24. All right. Now, a couple things I probably want to do with this answer is reduce it, 1, and then 2, I need to check it. Excuse me. So you might be able to do this best on the calculator, I would say. All right, so to reduce the fraction on your calculator, what you're going to want to do is enter it in, negative 59 divided by 24, and get a decimal. There's my decimal. And then you can go ahead and hit math, frac, number 1, and that will turn this into a fraction. Now, if it could have been reduced, that would have reduced it for us. In this case, this is already reduced, so we're good to go. The other thing I just need to make sure of now is that going to give me 0 when I put it in on the bottom? So if I do 2 times, and I can just go back up here and grab it, negative 59 over 24, plus 5, just make sure this doesn't equal 0. It is not 0. I really don't care what it is. It is not 0. So I know that this answer is okay. And we can use that answer and move on. All right, here we go on number 7, getting a little bit more exciting. One fraction equals another one, so we're going to cross multiply. I'm going to multiply those 2 things, and I'm going to multiply those 2 things. And then I'll do these ones on the side this time. So doing the 1 in blue here, x minus 3 times x plus 2, I'm going to double distribute, and I get x squared plus 2x minus 3x minus 6. Combine my like terms, and we get x squared minus x minus 6. Then I'm going to multiply x plus 5 times x, and again you can distribute backwards if you want, and that gives me x squared plus 5x, or you could rearrange the order, but now I need to set these 2 pieces equal to each other. And we get x squared minus x minus 6 equals x squared plus 5x. Now, to solve this, we've got the x squared. So now this is a different type of equation. This is a quadratic equation. And to solve a quadratic equation, you need to set it equal to 0. The good news here is when I subtract x squared from both sides, they kill off, and we're back to a linear equation. That won't always happen. But now I'm going to go ahead and solve for x. Adding x to both sides, I get negative 6 equals 6x, and divide by 6, I get x equals negative 1. I need to check my answer, and again, you only have to check in the bottoms. Make sure it's not going to be 0. Nope. Not going to be 0. Nope. So that is my one and only answer, and we are good to go. All right, next one. We got a proportion. Let's cross multiply. 5 times 2x minus 8 gives us 10x minus 40. X minus 4 times x gives us x squared minus 4x. Again, we have the x squared, so we have a quadratic, and we must set it equal to 0. Always move everything to the x squared side. So if we subtract 10x from both sides and add 40 to both sides, I get 0 equals x squared minus 14x plus 40. And now we have an easy trinomial, so I'm going to go ahead and factor that. Things that multiply together to give you 40 and add together to give you negative 14 or negative 4 and 10. Set those up in factored form and set equal to 0. And so I get x equals 4 and x equals 10. And now again, I need to check my answers in the bottom. If I plug in 4 here, 4 minus 4 is 0. That is bad. So that is an extraneous solution, our first one, and we are just going to go cross it out and get rid of it. If I plug in 10, 10 minus 4 is 6. 20 minus 8 is not 0. So 10 is my one and only answer. All right, here we go. Fraction's getting bigger, but still just a proportion. So let's cross multiply. When you cross multiply, you should get 9x squared minus 27x when you distribute, and 3x cubed minus 18x squared plus 27x when you distribute the 3x. Now, again, this is not a quadratic, it's a cubic, but I still, anything higher than just an x, I want to set it equal to 0, and I want to move everything to the higher power side. So I'm going to subtract 9x squared and add 27x. So we get 0 equals 3x cubed minus 27x squared plus 54x. And now again, to solve this, we're going to try to factor. Always pull out a GCF first. In this case, we can divide everything by 3 and an x. So I'm going to pull out a 3x, and I get x squared minus 9x plus 18. And now that is an easy trinomial, so I'm going to go and try to factor that. Things that multiply together to give us 18 and add together to give us negative 9 are negative 6 and negative 3. So this will factor to 3x times x minus 6 times x minus 3. Don't lose your GCF. And now set your pieces equal to 0, and I get x equals 0, x equals 6, and x equals 3. Before you circle your answers, again, go back and double check and plug these into the bottoms to see which ones are going to set it equal to 0. Again, this can easily be checked on your calculator, just plug in using your calculator. And once you plug it in once, you can just go back and highlight and then re-enter in underneath your, replace the zeros with your other numbers. Here I went and replaced the zeros with the 3s, and I'm just making sure I don't get zeros. If I get 0, that's bad. That is an extraneous solution. So after testing the first bottom, 0 worked and 6 worked, but 3 did not. So I got to get rid of the 3. Now I need to test it in the other bottom. When I checked in the other denominator now, the x squared minus 3x, the 0 didn't work, but the 6 did. So out of the 3 answers, 6 is the only one that worked, and it is my one and only answer. You have to check answers. I always tell my kids I'm going to take off more points if you give me an extraneous solution than if you just make a small mistake. Okay? Check your answers. It's easy to do. So in this case, x equals 6 is our one and only answer. All right, for this last one, I want you to pause the video now, and I want you to go and attempt this one on your own. Again, it is a fraction equaling a fraction or proportion, so we are going to cross multiply. Then I'll have you unpause it, and you can check your answer and your work with my answer and my work here. All right, here's a halfway checking point. You can look at yourself here, but when you cross multiplied, you should have got 4x squared minus 64 equals 4x squared plus 8x minus 32. I now need to try to set it equal to 0. Lucky for us, when we did that, you need to check your answer. The x squareds killed each other off, and so then I was left with a linear equation. I could solve for x, and I got x equals negative 4. Hopefully you didn't stop there and you checked your answer, though, because if you plug negative 4 in here, it's going to give you 0. Therefore, it's extraneous, And if my one and only answer doesn't work, the answer is no solution. All right, bye, boys and girls.